Hello everyone, welcome back to another video. And today we'll see the today's daily challenge. I'll try to solve it as fast as possible, and then also explain the tutorial. Minimum number of operations to make XOR equal to key. Okay, so we are given an zero indexed integer enums, and you can apply the following operation in number of times. Choose any element of array and flip a bit in its binary representation. Flipping a bit means 0 to 1 or vice versa. 2 1 3 4 for 1 there is first bit set only, so number of set first bit set in the nums array should be odd, is even actually. So for that I think there will be one operation, and second bit is even again, but 2 raised power 2 bit means third bit is set the number of that bit is 1, so I have to flip that one also. 2 is answer for this. So this is a pretty simple question. I just need a bit mapping for storing frequency. What are the constraints? 10 is to 6. Okay, I'll just write 32. 32 and 30 are enough. Right shift I, and so what this is just checking if ith bit of ith bit of current number C is set or not. What I will do, I will just increment bits of I plus plus. Now for answer, I will iterate through this map. A is also 10 to 6. So now first of all, what I will calculate if jth bit in K is set or not. And in ch2 will be bits of a mod 2. Now if if ch not equal to ch2, that means either one is even and other is odd, one is 0 other is 1, that type of condition, I have to increment counter because I have to flip one of the bits. So yeah, this was a pretty simple question. So in XOR you should remember some properties of XOR, and which property here was useful, that uh, if we check XOR on each independent bit, for example 0th bit, first bit, second bit, third bit up to 30th bit, instead of taking XOR of all elements we check them independently, and this XOR, this 0th bit, let's say this is my final XOR. Now in final XOR this 0th bit will contribute if the sum of this uh, set 0th bit in all the array is even, is odd, because taking XOR twice makes it 0. So taking XOR odd times, this even will get cancelled out and this will come out to be 0, and the remaining part will be remaining. For it, let's say I am taking XOR of x up to 2n plus 1. Now x XOR up to 2n will get cancelled out to 0, because XORing again and even times will make it 0. For example, if n was 1 itself, x XOR x is 0. This is the property of XOR, because we are taking exclusive OR but both the elements are equal. That means the XOR will be 0. And last remaining XOR is that additional x, that is in odd case mod to 1, and 0 XOR x will be x. So to make for to calculate the contribution of 0th bit in overall XOR, the sum should be frequency of that 0th bit set 0th bit in whole array should be odd. Now this similarly for each bit we can check the frequency sum, and so what XOR is required, that we required it to be equal to k. Now with parallel to this frequency map we will also calculate uh, k in binary form. For example, like this, let's say k was 1001. Now if we want XOR of that array equal to k, now we will check each bit individually. Now for 0th bit, this for in k 0th bit is set, so we require number of set bits in sum of number of set bits in the array should be odd. Now if they are equal to, they are even, I can just flip one of the bits and make them odd. Either I can flip a unset bit to set bit, then x, let's say x was even number, it will become x plus 1, or I can make a set bit unset, that will change the value of frequency of 0th bit to x minus 1. So for 0th bit I require one operation. Similarly, if for 1 I had, let's say, even number of, let's say 7 bits were set in array of first bit, but in k the bit is unset, so what I need is even number of set bits. So again I can either make one of the set bits unset or unset bit set, so it will come out to be 8 or 6. This bits operation is independent of all other bits. That's why this question is kind of easy. This could have been better if there was some constraints on elements or anything. So yeah, in each case where there is no match between mod 2 values of frequency and kth bit is set or not, I will require one operation to make them equal or make their parity equal. So that's what I'm doing via this code. I'm first calculating the bit map of the whole array, and then I'm iterating over bits and that map with parallel to k, kth all bits in k also, and ch is calculating if jth bit in k is set or not. ch2 is just calculating bits of j mod 2. So if it is even it will give 0, if it is odd it will give 1. Similarly, if this is jth bit is 1, this will give 1, and if jth bit is 0, this will give 0. And if both of them are not equal, I will just increment c and d. So yeah, I think this was not medium, but way easier if you know properties of XOR. So yeah, I think that's it from my side, and thank you for watching.